Hello student, welcome to online lecture series of Mahatma Gandhi College of Science Garsandur for the BSc final year semester 5th. In this semester we will start the first paper, organic chemistry. In organic chemistry we will discuss about second unit, that is organic synthesis via enolate. In this unit, that is unit 2, we will learn about definition of organic synthesis via enolate, active methylene compound, preparation of acetoacetic ester, that is also known as Claisen condition, and learn about their mechanism. Also discuss about acidity of alpha hydrogen, properties and reaction involving formation of mono, di and unsaturated carboxylic acid. Also synthesize various compounds, that is ketone, diketone, 4-methyl from acetoacetic ester. And also learn about the keto-enol tautomerism, preparation of diethylmalonate, properties and reaction involving alkylation, formation of mono, di and unsaturated carboxylic acid, and also synthesize glycine and barbaric acid from diethylmalonate. This is all the topic we will going to learn in this unit 2, that is organic synthesis via enolate. In this first part, we will going to cover this topic, that is the definition of enolate, difference between enol and enolate, and learn about active methylene compounds or reactivity of methylene group, and acidity of the alpha hydrogen atom. First of all, we will start organic synthesis via enolate. What is the organic synthesis via enolate? Synthesis of organic compound in reaction by formation of enolate ion intermediate is called as the organic synthesis via enolate. Any organic reaction, there is a generation of the intermediate. In this organic reaction, the main responsible intermediate is the enolate intermediate. Due to that enolate intermediate, we will give the desired organic compound. Such type of reaction we have to call as organic synthesis. For example, preparation of acetoacetic ester, also known as Claisen condensation. In Claisen condensation, 2 mole of esters, that is first mole and this is second mole, are condensed in presence of the sodium ethoxide. We will give the desired product, that is ethyl acetoacetate. This ethyl acetoacetate is formed due to the generation of the sodium enolate intermediate. How this intermediate is formed? When 1 mole of ethyl acetate is reacted with the base, that is sodium ethoxide. This sodium ethoxide is ionized. This sodium ethoxide is ionized at generation of the positive sodium ion and negative charge ethoxide anion. This ethoxide anion abstract, this is ethoxide anion, abstract the acidic proton of this methyl group, and there is a generation of the carbanion. This carbanion is neutralized by the charge of the sodium positive ion. This is the generation of the carbanion, and this carbanion is stabilized by undergoing the resonance or tautomerism, and it will be give the intermediate, that is sodium enolate intermediate. That sodium enolate intermediate is responsible for the further carry out the reaction. That means it is a main intermediate which is responsible to carry out the reaction. This sodium enolate intermediate is again reacted with the another molecule of ethyl acetate, and we will get the desired product. So this is the intermediate mainly responsible for the carry out the reaction of this in this organic synthesis. So Such type of reaction, any reaction is uh, we will get the product with the formation of enolate intermediate is called as organic synthesis via enolate. This is all about the organic synthesis via enolate and their definition. Now we will discuss about the difference between enol and enolate. What is the enol? Enol is the organic compound containing the hydroxylic group bonded to the carbon atom, which is doubly bonded to the another carbon atom. What is enol? Enol is an organic compound. It is an organic compound containing the hydroxylic group. Any compound. For the example, propanol. In this propanol, there is a hydroxylic group which is directly bonded this carbon, and this carbon is doubly bonded to the another carbon atom. There is a two functional group. One is a hydroxylic group. It is called as, when it is attached to the carbon, it is called as alcohol, and another is the alkyl group, alkene group, in group, E group. There is a double bond. Such type of arranging compound is called as a enolic compound. There is a two function group, that is a alkene and hydroxylic, that is another, also called as alcoholic group. This propanol is obtained from the acetone when it is undergoes the tautomerization, and it is converted in the enolic form. In means there is a double bond, and OL means there is a OH2. This is the example for the propanol. Now, enolate. What is the enolate? Enolate is any metal salt of enol, form of a tautomeric aldehyde ketones or ester. Any metallic salt of the enol. Suppose this OH is replaced with the sodium positive ions. Suppose in this OH group, hydrogen atom is replaced with the sodium positive ion. Such type of compound is called as a enolate. Here is oxygen directly attached to the carbon, and carbon is directly attached to the with the double bond with the another methyl group, CH2 group. Okay, and this sodium enolate is generated. Then aldehyde or ketone or ester is reacted with the base, any base such as a NaOH, KOH, sodium ethoxide. Such type of base is reacted with the aldehyde ketone and is extract the acidic proton from the active methyl group, and we will get the enolate ions. This is the difference between the enol and enolate. Now we will going to discuss about the active methylene compound or reactivity of the methylene group. What is the active methylene compound or active methylene group? A methylene group CH2, which is attached from one side or both sides by the electron withdrawing group, that is the CHO, that means the aldehyde, carbonyl, carboxylic, ester, cyanide, halide, NO2 group, etc., is called as active methylene group. Any methylene group is trapped in between the electron withdrawing group or directly attached to the one side or both sides with the electron withdrawing group. Such type methyl group is called as the active methylene. Also, another definition is when methylene group CH2 is placed between one or two electron withdrawing group, the hydrogen atom of methylene carbon become more acidic. Such methylene is called as active methylene. For example, we have to take the two examples, that ethyl cyanide and dimethyl malonate. In the ethyl cyanide, this CH2 group is a active methylene group because it is directly attached to the electron withdrawing group, that is the cyano group, and here this methylene group is methylene group is called as the active methylene group. Why? Because it is trapped in between the two electron withdrawing group, or it is directly attached to the two electron withdrawing group, that is the esteric group, that is the C double bond O C2 ester, and another side also it is bonded with the C double bond O C2 ester. Due to this esteric group electron withdrawing group nature, this is the group is electron withdrawing nature, is withdraw the electron density from that methylene group, from this methylene group, and due to the withdrawing the electron density from this methylene group get electron deficient, and it will be act as an active methylene group. Why it is act as active methylene group? Because this carbon get electron deficient, and that carbon is withdraw the electron from that uh, hydrogen atom between the hydrogen and atom, and this hydrogen atom get electron deficient, and it will be act as a acidic in nature. Like that, in case of ethyl cyanide group here withdraw the electron density from this methylene group, and that carbon get electron deficient. For the removing their electron deficiency is withdraw the electron density from that hydrogen atom, and this hydrogen atom get electron deficient and act as a acidic in nature. But what is meant by acidic in nature? Any hydrogen easily abstract by the any base, such hydrogen atom is acidic in nature. So due to the loss of the electron density from that hydrogen, it's act as a uh, acidic in nature, and such type of methylene group, that is CH2 group, is known as active methylene group. Why it is known as active methylene group? Because their electron density is withdrawal by this electron withdrawing group. The example is, that is a CHO, C carbonyl group, carboxyl group, ester group, cyanide group, halide, and NO2 group. Such type of group is directly bonded to the methylene group is such methylene group is known as a active methylene compound or reactive methylene group. This is all about the activity of the active methylene. Now we will discuss about acidity of alpha hydrogen atom. First of all, before discussing the acidity of alpha hydrogen, what is the alpha hydrogen atom? Carbon atom directly bonded with the function group which contain hydrogen atom called as alpha hydrogen atom. Alpha hydrogen. What is it? Carbon atom directly bonded with the function group which contain hydrogen atom is called as alpha hydrogen atom. Carbon atom is directly attached to the any functional group. Suppose this carbon atom is directly attached to this aldehyde group. Such first carbon atom is called as a alpha carbon atom, and the second carbon is called as a beta carbon atom. This first carbon atom you have to call as alpha carbon atom, and this second carbon atom is called as a beta carbon atom. The first carbon which contain the hydrogen atom is called as alpha hydrogen atom. Such hydrogen atom is acidic in nature. Why acidic in nature? The active methylene group are containing hydrogen atom are acidic in nature. This hydrogen atom which directly bonded to the alpha carbon atom is acidic in nature, and that hydrogen atom is known as a alpha hydrogen atom. This carbon atom is known as a beta, and that hydrogen atom is known as a beta hydrogen atom. Okay, you will know the concept, that is the what is the alpha hydrogen atom. And कोई भी कार्बन डायरेक्टली अटैच इसके होगा, फंक्शन ग्रुप से अटैच होगा, एंड उस कार्बन को डायरेक्टली अटैच हाइड्रोजन एटम होगा, उसको क्या बोलेंगे अपन, अल्फा हाइड्रोजन एटम और अल्फा कार्बन एटम इसे बोलेंगे. The compound containing the active methylene group which reacted with the base OH ethoxide amine etc. loses hydrogen atom to form carbon. This acidic alpha hydrogen atom, when it is reacted with the base, easily is loses that proton, that carbon loses the uh, proton and formation of carbanion state. For example, dimethyl malonate. Dimethyl malonate, this is the alpha carbon atom, and that alpha carbon atom, this is the alpha carbon atom. That alpha carbon atom directly attach to the 2 electron withdrawal group, that is a ester group. Due to this, it is acting as an active methylene group, and this active methylene group, alpha carbon atom, we withdraw the electron density from bonded pair of the another hydrogen atom, any hydrogen atom in between two, and this hydrogen atom acquire the partial positive charge, directly delta positive charge, and so it is shows the acidic in nature, and this will be easily abstract by the any base. Such base is the OH ethoxide amino, primary amine, secondary amine. These are easily abstract this proton, and there is a generation of the carbanion, and this carbanion is easily stabilized with the help of the resonance. This pi bond is shifted on that oxygen, and this negative charge is shifted on that carbanion. You have to get the enolate ion. This is the all about the acidity of the alpha hydrogen atom. Thank you.